Hello everyone. In this video we are going to learn the electromagnetic spectrum. So electromagnetic spectrum, when do we come across this term? So this term is mainly used in spectroscopy. So what is spectroscopy? It's the study of effect of electromagnetic radiation on matter. So we are going to learn about electromagnetic radiation and electromagnetic spectrum. So that we are going to learn in this video. So what is electromagnetic radiation? So electromagnetic radiation is nothing but our light. So whatever we see, those lights are called as visible light. So they are actually electromagnetic radiation. So but not only those visible light, but any light ranging right from radio frequencies to gamma rays, all are called as electromagnetic radiation or light. So electromagnetic radiation is the technical term used for light. The electromagnetic radiation, the name itself indicates that the light all kinds is radiated through conjoined electric and magnetic fields. So here you have to understand about the dual nature of light. So light has particle as well as wave-like property. So electromagnetic radiation is the technical term used for light. So where do you use this electromagnetic radiation? Yes, while tuning our radio, watching TV, sending SMS to our friend using mobile phones, or even while cooking in a microwave oven, we are using electromagnetic energy. So we always depend upon the energy every day. Without a mobile phone, we cannot imagine our life, right? That is the situation now. Yes, electromagnetic radiation is everywhere, even in sun. The energy what we obtain. Okay, the energy of radiation, the electromagnetic radiation. Actually, the electromagnetic radiation travels as shown here. The electric and magnetic waves are perpendicular to each other, and the propagation is also it is also perpendicular to the direction of its propagation. The energy of radiation can be represented by E is equal to h nu. So where h is the Planck constant. So you should also know the relation between the energy and frequency, energy and wavelength, and energy and wave number. So when we are dealing with spectroscopy. So the energy of electromagnetic radiation is E is equal to h nu. It can also be represented in terms of wavelength as shown in this second equation. E is equal to hc by lambda. Sometimes it will be represented in terms of wave number. So you should also know the relation between energy and wave number. That is E is equal to hc mu bar. So these three equations you have to keep it in mind when you are dealing with spectroscopy. So when a ray of light falls on the prism, a sequence of colors are produced, which we call it as visible spectrum. Here I have to say about this term spectrum. So what is spectrum? A spectrum is a group of different wavelengths and frequencies. It's a group of different wavelengths and frequencies. There are different types of radiation that include ultraviolet, visible, infrared radiation, and X. They are all called as electromagnetic spectrum. So, coming back to the point, so when a light falls on the prism, a sequence of colors are produced, as shown here. Um, that is Vibgea, violet, indigo, blue, green, yellow, orange, and red color. This is known as visible spectrum. So this is known as visible spectrum. Next to this, the higher wavelength side, that is to the right hand side, wavelength increases. To the left side, wavelength decreases. So visible light actually in the range of 400 nanometer to 800 nanometer. So the blue, the indigo, violet, indigo, blue, that is 400 nanometer range, and the red side there, that is 800 nanometer range. So the visible light ranges from 400 nanometer to 800 nanometer. So next to this, the higher wavelength side, that is to the right hand side, we have infrared radiations. The lower wavelength side, we have UV radiation. Actually, UV radiations are not visible to human eyes due to their lower wavelengths. So after UV rays, we also have much more lower wavelength uh, region, that is X-rays, gamma rays, etc. These X-rays and gamma rays are having lower wavelength radiation, lower wavelength radiation, but higher energy, radiation. They are all higher energy radiation. So gamma rays is the highest energy radiation. Frequency will also be higher. So with respect to infrared radiation, to the right side we have higher wavelength radiation, that is infrared radiation. So then after that, radio wave radiation. The thermal radiations with high temperature and high wavelength are called as infrared radiation. So after that we have radio waves. Radio waves are of highest wavelength but lower energy, that is lower frequency as well. Actually, these waves differ in their means of production and properties, but they have similar features. When they are described in terms of oscillating electric and magnetic fields, they are perpendicular to each other. Thus, they are called as electromagnetic radiations. In the electromagnetic radiation, both the electric and magnetic fields oscillate perpendicular to each other as well as perpendicular to the direction of their propagation. So the oscillation of electric and magnetic fields are perpendicular to each other as well as they are perpendicular to the direction of their propagation. All the electromagnetic waves are transverse in nature. Electromagnetic radiation travels with certain speed. The speed of radiation is equal to the speed of light in vacuum. That is C equal to nu lambda. These waves are traveling with the velocity of light and consisting of oscillating electric and magnetic fields perpendicular to each other and also perpendicular to the direction of its propagation are called as electromagnetic waves. And the waves with different ranges of frequencies constitutes an electromagnetic spectrum. So this is called as the entire picture. It is called as electromagnetic radiation, electromagnetic spectrum. Okay, once again I repeat, the waves traveling with the velocity of light and consisting of oscillating electric and magnetic fields perpendicular to each other and perpendicular to the propagation of direction are called as electromagnetic waves, and the waves with different ranges of frequencies constitute an electromagnetic spectrum. Okay, this is for the day. Thank you for watching. Happy learning.